Integrating various technologies, already existing and proven, with a synergistic combination between them, the Sultanate of Oman can produce an unlimited amount of food, of the highest quality and at the lowest production cost on the planet. In the evolution of humanity, water has been the crucial factor for the development of their societies. Currently, water can be brought to important places from it by a source of seawater. The drawback is usually the energy cost of desalination processes SWRO. By coupling the latest solar technology PV to a desalination plant, water can be produced in the Sultanate of Oman at a cost of less than $0.3 per cubic meter. By accessing a cheap source of water, thanks to the sea, the sun and the current cost of these technologies, generating wealth through food production only requires willpower. With the goal to be able to produce the best products, lowering costs in order to reach any world market with an advantage, another combination of known technologies is necessary, exploiting them with a dose of innovation. Greenhouses are, in themselves, an economic miracle, being able, with little water, to produce a much larger harvest than conventional agriculture. If hydroponic greenhouses are chosen, the need for fertile land is avoided, as the vegetables grow on artificial substrates. Working with hydroponic greenhouses, production per hectare can be greatly increased by using artificial lighting. Until now, it has had to optimize the electrical cost with respect to the increase in the harvest. However, with a source of electricity, with the lowest cost of the entire energy mix, $8 per megawatt hour in this project, the crop can be irradiated without any limit. At this point, the best seeds on the market transform all the CO2 in the environment into vegetables, until they stop growing due to the lack of this gas in the natural environment. Currently, in the most efficient greenhouses, gas is burned in electric generators and the exhaust gases are injected into the greenhouse, which accelerates its production by transforming that gas into vegetables, through photosynthesis. Although the burning of gas to enrich the environment in CO2 is very useful to increase production, it supposes an economic extra cost that must be optimized with respect to the extra growth of crops that it causes. In addition, an environmentally unfriendly carbon footprint is being produced. As a solution, these types of greenhouses must be located near thermal power plants, such as Al Rusail Electric Power Plant, taking the carbon emitted by the power plant and using it to enrich the atmosphere of the greenhouses, all without cost limit. On the other hand, this disruptive strategy couples the advantage of serving as extra income when trading green bonds for carbon absorption. The combination of technologies presented multiplies the production per hectare of any vegetable, by having unlimited water, electricity and CO2. The economic return, in addition to the social and environmental, is very high. Investment returns are less than 3 years. The project has other technological advantages. The desalination plant includes an attached chemical plant that uses the brine effluent to produce all the necessary reagents for the SWRO. This closed-cycle process only requires the supply of sulfuric acid and scrap. With these two inputs and with the brine, sodium chloride, the necessary reagents for the desalination process are produced: sodium hydroxide, hydrogen, chlorine, hydrochloric acid, sodium hypochlorite, ferric chloride and sodium bisulfite. This process eliminates the brine produced, transforming a problem effluent into an elimination of costs due to the synthesis of chemical reagents, in addition to the sale of excess reagents produced by this chemical plant. If required, part of the brine can be used in the production of detergents. The project includes a tomato concentrator plant, which, although it does not in itself involve technological progress, allows us to transform fresh tomatoes into a product with greater added value and for which we have a final buyer, Heinz. That is why, initially, the tomato was proposed as a star crop, although the greenhouse is capable of growing, with the greatest productivity, any other vegetable or fruit. The industrial complex has a voltage-boosting substation to inject electricity into the OETC 132 kV grid, as well as a high-voltage line to interconnect the PV plant with the Omani electricity network. An aqueduct to carry seawater to the designated land, due to lack of construction, and a CO2 gas pipeline from the nearby Al Rusail gas plant must be built. Included in the project is a plant to manufacture electromechanical products in which the PV solar trackers for the solar plant will be made, all the structures of the greenhouses and the desalination plant, in addition to all the piping, tanks and some basic operations of chemical engineering for the recycling of brine towards chemical reagents, as well as all the electrical instrumentation of the project. The above shows an achievement in technological innovation. Abounding in industrial development, the process also innovates in project exploitation systems, proposing the creation of a food production cathedra at the University of Technology and Applied Sciences at Muscat. The future Omani scientists and engineers who will direct the exploitation of this revolutionary industrial complex would be trained in it, in the doctorate cycle. The project management process begins with the development of detailed technical documentation, activity that would be carried out in a technical engineering office, which would be based in Muscat. In this technical office, our company management would work and train a select group of Omani engineers and scientists in various technologies. Engineers and scientists from the leading companies in the market would temporarily attend this technical office to support the detailed design of the project and to train, at the highest level, the group of Omani technicians. During this process, part of these foreign technicians would be recruited to form part of the cathedra of the University of Technology and Applied Sciences of Muscat. The objective is that, in 5 years, the cathedra can be held, by competition of merit, by one of the Omani technicians who have obtained a doctor's degree in it, leaving part of the opponents as members of the faculty of the cathedra. The goal is that the entire construction process, all the detailed engineering, all the patents, be Omani. The creation of the most refined state-of-the-art of food production technology should serve to project this technology, from the Sultanate of Oman to the closest countries, to spread throughout Africa. This food project is called to be the most efficient, profitable and environmentally friendly in the world. Its technology is capable of feeding that world, having no other limit than the one imposed by our will.